and intersecting chords and secant lines and their measures. And it turns out that it's pretty easy. So we have a couple different kinds of lines. First of all, these two lines that I've highlighted in yellow here are called chords. And so you want to know that word. That is a chord. And so here we have two chords that are intersecting, and they're intersecting inside the circle. So that point of intersection right there is on the interior of the circle somewhere. Okay. We also have a couple of different lines here. This is a tangent line. So tangent means to touch, if you remember that. So that is called a tangent line. And so that's one that's just touching the edge of the circle at one point. And then here, this line is called a secant. So this orange line is called a secant line, and it's a secant line just because it goes on forever, unlike a chord, which sort of stops. So we have chord. Here we have a secant and tangent line, and they are intersecting on the circle. So the vertex is on the edge of the circle, and that's important to point out. And then here we have two secant lines, and their vertex is outside the circle. And we're going to look at those tomorrow. They're nothing harder. I just thought that this would be nice to break up, really. And so today we're looking at the first two figures. And so we have, if two secants or chords intersect inside a circle, then the measure of the angle formed is equal to half the sum of the measures of the intercepted arcs. So I want to do a little highlight here. First of all, we have two secant lines that are intersecting on the inside of a circle. So that intersection is inside the circle. If I want to find the measure of angle 1, so that angle number 1 that is labeled, there we go, labeled there, is half the sum of its intercepted arcs. So the measure of angle 1 equals half of the measure of arc AD plus the measure of arc BC. All right, so it's half the sum of those arcs that the vertical angles eat up, essentially, okay? So remember, angle 1 happens to be on both sides because they're vertical angles, okay? And it is half the sum of those intercepted arcs that it eats. All right, does that make sense to you? So it's very similar to the inscribed angles. Inscribed angle is half of the arc. Well, this just moves the vertex a little bit, so it's half both of those arcs that it is technically equal to, okay? So if I wanted to find the measure of angle 2, again, angle 2, they have labeled here up top, but it's a vertical angle. So angle 2 above and angle 2 below are congruent. And when you think about the arcs that it would eat up, then it's these green arcs. And so the measure of angle 2 is half the sum of the arc that it eats. So the measure of arc AB plus the measure of arc DC. All right. So again, it just goes back to what arcs does it smush if you were to close the angle. Okay. So half the sum, which also means could twice the angle equal the sum of the arcs? Can you double your angle? Ooh, interesting. Okay, let's do a couple here. We're going to find each measure. we want to find the measure of angle AED. AED is right here. I'm just going to put a little orange dot. AED is that angle. And so I'm looking at the arcs. It would use arc AD. And the other side, its vertical angle, uses this arc BC. And so what equation can I write? Yeah. So our angle equals half the sum of these two orange arcs. So half of 45 plus 109. And that's it. Which, would you go ahead and tell me what that is? 77. All right. So 77 degrees. Let's look down at number 3. This is one from Delta Math. That's why it's very small, because I have to shrink it. Okay, so it says the measure of arc QE. So arc QE is right here, is 148 degrees. And the measure of arc LS is right here. It's 126 degrees. And it wants us to find the measure of angle LZS. LZS is this angle right here that I put a little dot in between. And so our angle, the measure of angle LZS is, the angle is half the sum of the arcs. So it's just half of what plus what? 148 plus 126. 148 plus 126 is 274. So half of 274 is, I don't know, it's 35. 37. 137. I was almost there. I had the 37 part done. Okay. Okay. Is this easy or hard? So easy. All right. Let's look at number 5. This one's different. It's asking you to find the measure of the arc. So it wants to know the measure of arc CDE. CDE is this whole arc. That's what we're trying to find. I'm just going to give it an X. That's what we're trying to find. And then you'll notice we have this 128 degree angle. And we have this opposite arc from the other side of that vertical angle. So how are we going to go about setting this one up? Good. I'm going to set it up in the traditional way, which says the angle. So I'm going to do the 128. The angle equals, so 128 equals half the sum of the arcs. So my arcs would be, the big arc is, we're going to call X, and our 73. So arc, 1/2 arc plus arc. And then what you said was double 128. And the reason we're going to double 128 is to get rid of the 1/2. I could distribute it, but the faster, easier, less annoying way is to go ahead and multiply by the reciprocal. So we're going to multiply both sides by 2 over 1. That gets rid of the 1/2, and I don't have to deal with fractions. What a blessing. All right, doubling 128, I get 256 equals X plus 73. And then what do you need to do to solve for X? Subtract 73. So we get X equals 183 degrees. Okie dokie. Let me see if, oh good. Will you try number 6? Take a second and try number 6 on your own. I'm going to try and read it. Let's see, YS is this arc right here. It says it's 180 degrees. And the measure of angle QBI is 137. So that's our little angle. And then we want to find the measure of arc QI. So that's what I'm trying to find. So I'm going to call it X. Go ahead and take a minute and set that up. Remember, the formula is, I'm going to write it down. The angle equals half the sum of arcs. And that's a good way just to remember it, the sum of the arcs that it intercepts. The angle equals half the sum of the arcs. Okay, did you guys get an answer? What did you get? 94 degrees. Okay, cool. Again, this is the setup. The angle, 137, equals half of the arcs. I really like highlighting. It's super fun. Plus, it looks pretty. All right, questions so far? Super easy, right? All right, this is like 6th grade math. 4th grade math? Not too hard. Okay. So turn the page. When our intersection is on the circle, this goes right back to when we had inscribed angles. An inscribed angle, something like this. This was an inscribed angle. And the inscribed angle, if you had an arc measure, let's say this was 120 degrees. If the arc was 120, what was the angle measure? 60. It is simply half the arc. This is the exact same thing. This angle has a vertex that is on the circle. So again, this vertex is on the circle. The same rule applies. It's half the arc that it eats. So the measure of angle 1, the measure of angle number 1, and this is the angle that is from secant line to tangent line. It's this whole angle right here from secant to tangent is half of the arc that it intercepts. So it equals half the measure of arc AB. It's just half the arc. So it is exactly the same as an inscribed angle. And then the measure of angle 2 starts over here at B and goes all the way around. That's the arc that angle 2 would swallow up if it were to close up. All right? So angle 2, and again, angle 2 is from secant line all the way to that tangent line out there. So that angle is, again, just half the measure of arc BCA, that big arc, okay? So it's just half. That's nice. It's not half the sum, just half the arc, all right? So let's look at number 8 and 9, and then I think we'll call it. Number 8, line CI is tangent to circle O, so you have a tangent line there. That's good. So C is on the circle. And it's a measure of arc, CUH. So CUH is this big arc right here, is 244 degrees. Find the measure of angle HCI. So we want to know this angle right here. I'm going to call it X. That's the angle we're looking for. How do I set this up? The angle is half the arc. That is the setup. So how should we write? What number should we use?
244.
Equals what?
244 divided by 2.
Okay, so x equals half of the arc that it eats, so half of 244. So that's 244 divided by 2, which is what you said, and that would be 122. The angle is half the arc. The angle is half of the arc. Let's look at number 9. We have another tangent line here at point X is the tangent point on our circle, and XT is a secant line. The measure of angle TXZ, so that's this angle right here. That angle is 69 degrees, and we want to find the measure of arc XT. And since that's what I want to find, I'm going to call it X. How should I set it up? Just 69. The angle is 69 equals half of our arc, and our arc is X. So the angle is 69 degrees, and it equals half of our arc. And then how do I get the X by itself? By 2, multiplying by 2 over 1, multiply by the reciprocal. So we get X equals 138. Thank you. Okay, good. So we've got half the sum or just half the arc. Angle equals half the sum or angle equals half the arc. That's the only thing you got to remember today. You got any questions for me?